Welcome, everyone. We are so excited to welcome many of you back for another session as part of the 2021 Climate Leadership Series. I'm Leanne Osborne, Strategy and Planning Manager at the Climate Registry. For those of you who may not be familiar with the Climate Leadership Conference, we, in coordination with our co-host, C2ES, have convened sustainability professionals for 10 years running to address today's pressing climate challenges through policy, innovation, and business solutions. While we regret not being together in person this year, we are happy to expand our reach and bring together so many dedicated climate professionals during the course of this virtual series. Following nearly a dozen sessions thus far, we continue to bring our CLC audience webinars and workshops designed to give sustainability professionals like you the tools to act, to meet ambitious climate goals, and hopefully leave you feeling inspired. Today's session is focused on decarbonizing the built environment, and we'll dive deeper into the technologies, innovative strategies, and complementary policies that will drive these efforts. We encourage you to participate in the conversation. To connect with your colleagues and submit questions for our panelists, please use the chat function to the right of your screen. Next to chat, you can use the People tab to search for and connect with specific colleagues. If you require assistance during the event, please email questions@climateleadershipconference.org. Today's sessions will be recorded, and the recordings will be made available on the CLC YouTube channel in the coming days. We are grateful for the support of our 2021 sponsors. Special thanks to headline sponsor Bloomberg Philanthropies, our host city sponsor Entergy, platinum sponsor Dominion, and gold sponsors Intel and SoCal Gas. All right, now I am thrilled to send it over to our panel and welcome them up to the stage.
Thank you, Leanne. And it's such a pleasure to be invited to participate in this. My name is Eric Werling. I'm with the Department of Energy, and I direct a couple of programs there in the built environment in the Building Technologies Office. But I'm not going to be one of the panelists. I'll be moderating for you today. I want to first thank the Climate Leadership Conference for inviting me to be part of this exciting event. It's really exciting. And then the staff at the Center for Climate Energy Solutions and the Climate Registry who participated in organizing this. It's in my impression, it's very well run, and I'm very excited to be part of this. We also have 4 panelists who bring a wide array of expertise to this panel, which I'm just so excited about. I'm going to go ahead and read their bios first. Hopefully, then we can just get into individual remarks by each of them, and then we'll start the discussion. We intentionally do not have PowerPoint slides today. We're hoping to stimulate a good discussion about this huge challenge. And I want to start by mentioning that by almost every measure, buildings are the largest sector of the US energy economy. Buildings use 40% of the energy in our entire economy in the US. Almost 40% of the CO2 emissions are the result of building activities. 75% of electricity use is due to building consumption, and peak demand contributions for buildings are more than 80%. So it's a pretty substantial part of the climate change response is going to sit on our shoulders in the built environment. So those of you in sectors who can address building emissions and building energy use, we need all hands on deck. Fortunately, I'm very excited to be doing this just a few days after the president signed the infrastructure bill. And my office, the Building Technologies Office at the Department of Energy, has a very significant new mandate within that new legislation that will essentially multiply times 5 the funding that we've had historically in recent years to support adoption of advanced codes, building codes, that is. So we also have everything else in the pipeline, from early stage research and development through market transformation and scaling activities. So extremely exciting time. My office director, David Nemso, has frequently said, fasten your seatbelts, folks, we're going to be busy for the next few years. So very, very exciting times, and I'm really excited to be part of this. So let's kick it off and get into the panel session. I have I'm very excited to have 4 panelists to join me to talk about their thoughts with regards to helping to move towards a zero net emissions building sector over the next few decades. And we've intentionally put them in an order from near term, in other words, stuff that's happening today that's improving the sustainability of buildings already, all the way towards what are some of the hardest longer term challenges we have to deal with. And like, how do we address the embodied carbon emissions and energy, embodied energy in buildings, some of the longer term challenges that we'll be facing. So along the way today, we'll have the pleasure of 4 distinguished colleagues, and they are first Scott Tu, who is the VP of Sustainability and Managing Director of the Center for Energy Efficiency and Sustainability at Trane Technologies. Scott has been serving as the Vice President of Sustainability and co-founder of the Center for Energy Efficiency and Sustainability at Trane, CEES, and has been responsible for forward-looking and sustainability initiatives aimed at transforming or transitioning to more efficient and clean climate-friendly solutions, minimizing resource use within company facilities, etc. And Scott has a fairly long list of accomplishments, and in the interest of time, I think I'd like to skip those, but I would like to highlight that Scott's remarks, we're hoping, will really highlight the proactive corporate actions that are happening today that are going to help lead us to zero emission buildings. So I'm really excited to hear Scott's remarks. The next speaker, Katrina Managan, is buildings team lead at the Office of Climate Action, Sustainability and Resiliency for the City and County of Denver. Katrina leads the high performance building and homes team for the Denver Office of Climate Action, Sustainability and Resiliency. The team's working to make all new and existing buildings and homes in Denver net zero energy, more sustainable and more resilient. And Katrina has been with the city for 7 years and led the work to develop the benchmarking ordinance for existing buildings, the Green Buildings Ordinance, the 2019 Denver IECC, the first ever Denver Green Code, and the Energize Denver Building Performance Policy. So I think it's going to be very exciting to hear from Katrina, how did Denver do it, and how our local and municipalities, in some cases, like in Denver, leading the way towards zero emission buildings policies. So with Scott and Katrina, it's between corporate action and local jurisdictions, we are already on the way to getting to zero emissions in the building sector. Then great pleasure of also introducing Steve Harper, who is the Global Director, Environment and Energy Policy at Intel Corporation. Steve is the at Intel. In that capacity, he's been responsible for advising senior management and leading company influencing efforts on a wide variety of topics ranging from chemicals management to energy efficiency, water policy, the role of Intel's products in helping meet society's toughest sustainability challenges, etc. And he's got a long career in a variety of different efforts, including some public sector work. He and I both worked at ICF Consulting supporting these activities, etc. So Steve's work at one of the premier IT companies in the country, I think, sets him up to be the perfect expert to talk about the digital climate solutions that can help the building sector to actually efficiently move towards meeting these goals. And we acknowledge at the Department of Energy that smart technology is a huge need that we'll have to leverage in order to get to the lofty climate goals that we've set. As an aside, I asked for some sort of personal way to personalize these introductions. And just to give you a sense of Steve's sense of humor, he told me that he failed to reach his original dream of being a rodeo clown. I'm really glad that he's not a rodeo clown now, and that he's actually contributing to this great discussion. And finally, at the bottom of your screen, Christie Gamble is a Senior Director of Sustainability for CarbonCure Technologies. And Christie drives CarbonCure's mission to reduce 500 megatons of annual carbon emissions from the cement and concrete industry. CarbonCure manufactures a technology that enables concrete providers to utilize post-industrial carbon dioxide in their manufacturing processes in order to achieve significant embodied carbon reductions without compromising concrete quality. So, and I could go on about her activities as well, but really just to point out, most importantly, I think that Christie represents the part of the building sustainability area that is in our experience at DOE is the newest sort of frontier that we're going to have to address. A whole lot of metrics and analysis and supply chain and coordination with industry, et cetera, that's going to be required above and beyond just better designs and better operation of buildings. So it's the whole gamut. Real excited about that. Christie is a Canadian, and interestingly enough, she's a top-ranked competitor on the World Curling Tour. So quite a panel. I'm so excited to hear everybody's opening remarks. And why don't we kick it off with you, Scott?
Okay, thank you, Eric, and thanks everybody for your time today. It's a great panel. I agree with Eric. We have a diversity of experts, and the topics are just as wide ranging. So great to be here. Even though we don't have rodeo clowns, we can still have a good conversation, I think. So I am happy to be here. Scott, too, as Eric mentioned, I work with Trane Technologies. For those who are not familiar, Trane Technologies is a leader in heating, ventilation, and air conditioning systems and solutions. Our systems are geared towards making high-performance buildings both healthy, comfortable, and efficient. 1 out of 2 buildings in North America is a Trane Technologies. We're providing some type of solution. 1 out of 2 commercial buildings in the U.S. And why I'm here today, one of the questions before us is, Eric gave a tip-off to that when he mentioned the amount of energy that's consumed by buildings. We all know that fact. If you convert that, though, you'll also find out, even though he mentioned how much electricity is used by buildings, I can take that one step a bit deeper and let you know that roughly 40% of the building's electricity use is aimed at heating and cooling. And that equates to roughly 15% of the global greenhouse gas emissions. So the burden of greenhouse gas that you can directly attribute to heating and cooling, providing comfort in the spaces we spend our time, is related to heating and cooling. That's 15%. That's a large slice. A lot of that is heating. And one of the things I want to talk about in a few minutes or later today would be what we see on the horizon in terms of innovation in that space. A bit of background, though, about the company and what that finding led us to do. We sort of internally began to grapple with this issue of 15% of the greenhouse gas burden is directly related to what the company provides to the market. And that led us to create what we call the Gigaton Challenge, we've committed to reducing our customers' carbon footprint, meaning our product emissions, Scope 3 emissions, by 1 gigaton. It's the largest science-based product emissions reduction commitment by any company ever. And it is in front of us, and it's leading to some great innovation. It has galvanized our customers, it's galvanized our supply chain and our people around really 3 big things. One is systems level efficiency, or what we would call energy optimization. 2 is accelerating some clean technologies, things that did not exist just a few years ago, but now are moving to scale in the market. And thirdly is our efforts and leadership in transitioning out of high global warming potential refrigerants. Refrigerants are greenhouse gases. We use them as a raw material inside of our solutions. And we are moving to transition out of those ahead of the 2030 deadlines, well ahead of regulation. And in fact, our R&D efforts are transitioning the entire industry sector ahead of others and sort of leading the way there. So our journey has taught us a lot. I'm happy to share some of the learnings as we go through the discussion this afternoon. It's great to be here.
Thank you, Scott. And Katrina, are you ready to go?
Hi, everyone. It's great to be here with you today. Here in Denver, we are working, as you heard in my introduction, to bring new and existing buildings towards net zero energy by 2040. And I'll talk a little bit about what we're doing with each of those. So for new buildings and homes, Denver is in a home rule state of Colorado, so we adopt our own building codes. We update our code every 3 years, following on the model codes from that IECC, but we do a bunch of amendments in Denver to take the codes further towards net zero energy. For example, our 2019 code was 15% better than the 2018 IECC model codes. And so we're working to bring new buildings and homes to be net zero by 2030 through our code update cycle. We have just started looking at embodied carbon also, to touch on something I know Christie will dive in deep on. We did our first embodied carbon inventory, and through the code adoption process plan to take some first steps when we update the code in 2022 towards addressing embodied carbon through construction materials in our building code. And then just to summarize briefly what we're doing around existing buildings, we just are in the process of finalizing a building performance policy that will go through the final vote in City Council on Monday next week. So look for news that we have our Energize Denver ordinance passed and in place. And that ordinance will require that all commercial and multifamily buildings over 25,000 square feet reduce energy use 30% by 2030. Every building will have its own trajectory to a target for that building type, but in aggregate across the whole building stock will be 30% more efficient by 2030. Renewables fully count for compliance, so they subtract from energy use under that ordinance. And then also part of that performance policy is that we will require the electrification of space and water heating equipment upon equipment replacement starting in 2025 in commercial and multifamily buildings. So those are for the easy to electrify system types. It phases in a little later for harder to electrify system types. We will have lots of incentives and support for our community. We're really fortunate because in Denver, our office is funded by what's called the Climate Protection Fund. We have $40 million to support our community through this climate transition every year. And we're going to be really focusing those dollars and our implementation of these policies to deliver benefits to the most under-resourced communities in Denver. Improving energy efficiency can reduce energy burden for low-income and under-resourced people. Of course, moving away from natural gas for space and water heat has huge self-health and safety benefits. We know that 30 to 40% of low-income homes in Denver have carbon monoxide leaks in their natural gas equipment, and they don't have carbon monoxide detectors. And so there's really big co-benefits to decarbonizing that space. And just because I know we're talking to a national and sometimes a global audience, there's a couple small things I want to touch on electrification, and I'll pass it off to the next speaker. But electrification, some of the questions we most often get are, is this really lower emissions? And our local utility, Xcel Energy, has regulatorily required plans to be 80% renewable by 2030. And so moving to heat pumps is a really big climate benefit. And their grid can support that transition because we're a summer peaking system today. So they've got lots of capacity to add winter heating load. Heat pumps are 200 to 300% efficient, so they use a third as much energy as gas systems. So we're really excited to start that transition off of gas onto renewable electric heat for our buildings across Denver. Looking forward to the discussion.
Fantastic. Thank you, Katrina, and congratulations on getting as far as you have with those ordinances. Next up is Steve Harper from Intel.
Yeah, thank you, Eric. I'm excited to be here, and particularly excited to follow Katrina from Denver. I'm Denver born and bred, and a few years ago, the conference was in person and was held in Denver. And I got to see a number of the things that Katrina's office and other folks in Denver are doing to advance climate mitigation. And I encourage people to check it out online because there is some pretty interesting and exciting stuff going on. I want to focus on digitalization, as Eric indicated. We have been big supporters of C2ES for many years, including supporting their recent digitalization report, which is on their website, and I commend it to people to check into because I think it's a very good summary of both the technology opportunities that are out there as well as the barriers to those technologies finding a niche in the marketplace, as well as some policies the government can pursue to address those barriers. You know, the technologies are important. You've got building energy management systems and home energy management systems, smart heating and cooling systems, connected appliances, grid infrastructure, grid ready infrastructure systems, and digital twinning. And I should mention that we're one of the founding members, along with Trane, of a group called the Digital Climate Alliance, which is a group of companies that are focused on trying to address policy barriers to the uptake in the marketplace of digital climate solutions, including in the building sector. You know, the barriers that are out there are considerable in number. The most important one is lack of information, you know, a classic market failure from an economist standpoint. A lot of the technology solutions that are already out there just are not well known, particularly by homeowners or by small and medium-sized businesses. There are financial constraints. You know, how do you finance this stuff where there, in some cases, is significant upfront cost, relatively short payback, but, you've got to have mechanisms to get through that mental and financial barrier, particularly for consumers and small and medium-sized businesses. There are regulatory issues. In a lot of cases, PUCs are just not in a position to approve utility programs that would encourage these systems, because it's not the traditional thing that utilities get approved and rate-based by the PUCs or state commissions. There are technical issues around interoperability of different types of equipment, hardware and software. Broadband. One of the great things about the infrastructure bill is the attention that's being paid, the money that will get spent to advance 5G broadband. Cybersecurity issues, privacy issues. These are just the highlights of some of the barriers to be overcome. And I'll just finish by talking about how government agencies, including Department of Energy, can help address those barriers. First and foremost is RDD&D. And there are a lot of technologies out there that are proven on the bench scale, proven in the laboratory, but not out on the ground. And so it's hard for a utility to get a PUC to approve the rate basing of an investment in a technology that hasn't been adopted and proven by 10 or 12 or 50 other utilities around the country. Economies of scale, new products that come out, new solutions that come out, typically have high per unit cost. And government procurement can be critical to driving down the per unit costs, introducing economies of scale rather than diseconomies of scale. That makes it a lot easier for the private sector to take up similar investments. Outreach. DOE has a lot of existing outreach programs. There needs to be more outreach on these technologies, again, especially to small and medium-sized enterprises. And then finally, something near and dear to Intel's heart, which is supply chain problems. There are a variety of reasons why there's a shortage of semiconductor chips. And they're mostly on the lower end of the price scale, not the upper end where we tend to occupy market share. But in these Internet of Things technologies, particularly the silicon that goes into them typically is not very expensive. And those are the types of chips that today are in very short supply. And the government can help and is helping, and hopefully through something called the CHIPS Act, which is pending congressional funding, which will provide incentives for a substantial increase in semiconductor production capacity across the whole range of semiconductor products. So I look forward to hearing questions and participating in the discussion.
Thank you, Steve. And I assure you I was taking notes, and we are talking about all four of those issues that you mentioned and planning for scaling up. So I look forward to connecting.
Hi, everyone. Thank you, Eric. I don't know if the computer froze on my end or if others in the audience saw that, but if it was something that everyone else saw, it's an honor for me to be here. And thank you, Eric, for introducing me. It's also an honor to be following, as a Canadian, following our former Prime Minister, Stephen Harper. I'm kidding.
Yay.
Steve had made that joke as we introduced ourselves to each other earlier, and it really made me laugh. So in any case, I'm here to talk to you about two particular things that relate to transforming the built environment. For starters, I'd really like to discuss the importance of reducing embodied carbon in the built environment. Secondly, I'd also like to highlight the concept and the opportunity to reimagine CO2 as a solution in the built environment. So with that, I'll give a little bit of context about myself before getting into this. I am Senior Director of Sustainability with CarbonCure Technologies. And CarbonCure is a Canadian clean technology innovator who is working with the cement and concrete industry to reduce the carbon footprint of concrete. So we have developed a technology that beneficially repurposes carbon dioxide. So we're utilizing post-industrial carbon dioxide as a material in concrete in order to reduce its carbon footprint. Now, in addition to my work at CarbonCure, I'm also just completing the end of my 3-year term as a board member on the Carbon Leadership Forum. So if you're not familiar with the Carbon Leadership Forum, I highly recommend taking a look at www.carbonleadershipforum.org. It is a collection of owners, architects, engineers, contractors, many different kinds of stakeholders who are aligned on a mission to eliminate embodied carbon from the built environment. So with that in mind, what exactly is embodied carbon? Well, embodied carbon is the carbon footprint of a building or infrastructure project before the lights are turned on for the first time. Historically, when we've talked about reducing the carbon footprint of buildings, we've almost always been referring to the operational impact of buildings. So this is the carbon impact that comes from the heating and the cooling systems, the energy usage, lighting, etc. And there's been a lot of innovation in this space. And there, of course, needs to continue to be innovation in this space. But comparatively, there's been very little done to really look and understand embodied carbon. So the carbon footprint that comes from the manufacturing of the building materials itself and the construction of the building or the infrastructure. And what's really important to note is that embodied carbon is expected to account for a significant portion of the carbon footprint over coming years. Over the course of the next 4 decades, it's estimated that across the globe, we're building another New York City every month for the next 40 years. And of that new construction, embodied carbon is expected to account for about 50% of the overall carbon footprint. So that really means that that's a significant impact. And on top of that, it's quite time sensitive. If we're to look at reducing operational impacts of buildings, in theory, over time, we can continue to retrofit buildings with more efficient operating systems, net zero energy systems. But once the embodied carbon impact has been made, there's no getting it back. Once the carbon that's emitted from the manufacturing of the building materials through the construction of the building itself has been emitted, there's no getting it back, with the exception of perhaps removing that carbon dioxide from the atmosphere directly. So that really creates an urgency to start addressing this problem now, and we need to address it quickly and globally. Now, with that, I'm going to segue into some opportunities for the built environment to reimagine carbon dioxide as a beneficial material to reduce that carbon footprint. So CarbonCure is very proud and humbled to be a leader in the emerging industry of CO2 utilization. CO2 utilization is the concept of using CO2 that has been captured from post-industrial sources or perhaps captured directly from the atmosphere in other kind of product manufacturing. In the case of CarbonCure specifically, we are introducing carbon dioxide into concrete, where it chemically converts into a mineral and becomes permanently embedded in the concrete. So the concrete actually has an opportunity to act as a carbon sink. So this is really exciting. What's also important to note is that concrete as a material is the most abundant material on the planet. It's actually the second most abundant material, period, after water. And because of its abundance, it does have a large impact on carbon emissions. The cement industry alone, so cement is the key ingredient used to make concrete, cement production results in about 7% of the world's carbon footprint. And so if we were to really tackle concrete, we could see concrete as an opportunity to really achieve meaningful embodied carbon reductions. And so with that in mind, as an innovative solution working to reduce the carbon footprint of concrete, working with the concrete industry to decarbonize, we do run into a number of challenges. We have many great partners in the concrete space who have adopted our innovation along with other solutions to reduce that carbon impact of concrete. And the challenge we often run into is industry acceptance, procurement practices, policy. And so I'm really excited to dive into this conversation with my fellow panelists to talk about, what can we do across stakeholders to really enable innovation across the industry. So with that, I'll hand it back. Thank you, Eric.
Thank you, everyone. It seems our moderator, Eric, is having some technical difficulties. My name is Mahmoud Abu Naga. I'm a solutions fellow at C2S. I work on energy system analysis and technology analysis as well, and I will be happy to continue the conversation with you all till we have Eric back on the line. And it seems our audience are already engaged enough in the conversation, and they have been posting their questions. And the first question is for you, Christie. What building codes need to be changed to enable use of the concrete, the recycled concrete that you were talking about in different products, including sidewalks, reinforced concrete pillars, bridges, and flooring?
Sure. Well, specifically, which building codes? There are many. So I'll speak in generalities. Essentially, concrete procurement is a type of procurement that has operated in the same way for a number of decades. And there are certain types of regulations and practices that exist today that are pretty prohibitive for new innovation to come into play. And so for organizations, especially government organizations, whether it's federal, statewide, municipal, one of the best things that can be done right now is to look at procurement policy specifically to really review the types of procurement practices and specification regulatory barriers that exist to innovation. So I'll get into specifics just as an example in concrete. This is what I know. I do believe this can apply for other types of procurement as well. Within concrete, specifications often are quite prescriptive. They require very finite amounts of material. They basically will often tell the concrete producer exactly what kind of concrete to provide. And it doesn't provide room for innovation. And yet there's such a huge opportunity to make some meaningful carbon impacts if you are a government that is committed to climate reduction or climate impact. And so just for example, take a look at all the sidewalks that are being poured across a city. That sidewalk itself is often, the concrete that's used often has a much higher carbon footprint that's necessary. So removing those types of barriers and just really adopting what's considered to be more of a performance-based specification. So a specification that says, this is the kind of strength that I need for my concrete. This is how smooth I need it to be. That will enable concrete producers to be able to offer solutions that can help to reduce that carbon footprint. And there can be significant carbon reductions achievable today if that kind of policy were in place. And Eric, you are back. Welcome.
I am. Thank you. Sorry for the internet glitch. I guess it happens to all of us at one point or another. I'm just glad I could make it back, and thank you, Christie, for filling in, and Mahmoud as well. The issue that the question that you just answered, Christie, that was fantastic answer. It makes me think about, though, the question of how about existing buildings and infrastructure. Is there anything regarding managing end of life, or this is maybe to all of the panelists, because the buildings last a long time. What kinds of waste reduction, recycling, that sort of thing can fit into the policies? It's kind of an extension of the embodied carbon discussion, but I think it goes to all the other issues that we're dealing with as well. Anybody have any thoughts about the existing building stock and how that fits into your expertise?
Yeah, I'll say something, Eric. This is Scott, just about existing buildings. I mean, we have to focus on existing buildings. I know it's great fun to always focus on design for new buildings and making them, as least of a burden on the environment as possible. But existing buildings are really where it's at. It's also where the biggest opportunities are. And there's more opportunities there now, I think, than ever before. Whether we're talking end of life, I mean, the mechanical systems where companies like Trane have exposure, most of our systems are highly recycled. Most of them are made of metal that has a value. We're at 95+% recycle rate for ours. We've tracked them and traced them. We also have recycle programs in place. And also a lot of the sort of leading edge advancements are now in designing those systems for circular life, and which pulls into the things we were just talking about, from everything from the embodied carbon footprint, but also it takes into account what happens at end of life. Actually, we're trying to design out end of life and just design for circularity is our commitment. And so we're redesigning systems so that they actually can become something else, or can be refreshed, remanufactured, or revised in place, and can continue on with a new life inside, in situ, inside the building that it's at. So we're very focused on existing buildings, and I think that's where the great opportunities are in terms of decarbonizing that sector of the economy.
That's a super answer. Thank you, Scott. And that, following on that, I wonder, Katrina, if you have any thoughts about, dealing with policies at a local level that address existing buildings and how that relates to this challenge that Scott and Christie were just discussing.
Yeah, absolutely. And I don't have the numbers right on the top of mind, but embodied carbon, when we did our embodied carbon inventory, and if you just Google Denver embodied carbon inventory, you'll find it, showed that, as Christie said, embodied carbon is a really significant contributor to the total carbon emissions over the life of new buildings. And as operational carbon goes down to zero by 2030 for us, it will become almost all of the emissions from our new buildings. And in Denver, we're building really quickly. So about half of our building stock will be new by 2050. So we are definitely interested in how to start addressing embodied carbon. We do have some really initial concepts that we're going to consider with our code committees, as I mentioned during the 2022 code cycle. And it may be things like just reporting the embodied carbon of materials used in construction sites. We could also, there's some materials where there are low carbon options available, like concrete and steel, and there's sufficient data to sort of set limits for how much embodied carbon can be used in those materials. And so the code committee next year will really be making decisions on how much of that is appropriate to put into just our base code requirements versus what might go into our voluntary Denver Green Code. And our Denver Green Code today does have compliance sort of options within it around material recycling, reuse on the construction site and what happens with construction materials. So it's something we're starting to look at because it will become a bigger and bigger part of our emissions as we bring the operational emissions down to zero. But at the same time, we've got to actually get operational emissions down to zero. And that is also a really big lift. That's where our bigger focus has been. But we're turning more and more towards embodied carbon here over time.
Right. That's super encouraging, Katrina. It also, this discussion is also leading me over to Steve, because a lot of what you're talking about with regard to reporting and the data that is needed in order to, track where the biggest emissions are coming from, et cetera, we're eventually going to need to have better, IT solutions for managing all that data, especially with regards to existing buildings, because there's very limited data that's available. One of the questions we received ahead of this panel was about the difficulty of collecting data. And I wonder, Steve, if you could address emerging technology for collecting data on buildings and the sort of the life cycle of the data related to the building's embodied carbon emissions, operational carbon emissions. That there's just so many technical challenges on that side. I wonder if you could take it a little further.
Yeah, I'd be glad to, but I want to emphasize that we're both a provider of solutions in that area, excuse me, as well as a consumer. We're in the supply chain of our customers. We don't sell directly, for the most part, to the consumer. We sell to the computer OEMs and the server OEMs and into the IoT market for sensors and data gateways. And so, yeah, I could speak to that, and I'll turn to that in a second. But it turns out we're under a lot of pressure from those customers to reduce the carbon footprint of the product we provide them. And it used to be that most of the carbon footprint, most of the energy footprint of a PC or a server was in the energy consumption in their use phase, which is still largely true for servers. But for PCs, your laptop is already so efficient that the use phase contribution to the life cycle, the carbon life cycle of a PC is a relatively small slice. Embedded is huge. The complexity of the product we make is so finely tuned that there's just a lot of energy and a lot of materials that go into making a very small end product. And so our customers like Dell and Lenovo, et cetera, are turning to us to spend more of our effort on our embedded carbon. And what that means for us in both new buildings, and we're building 2 new factories at $10 billion a pop in the United States, and we're looking to upgrade our existing factories around the world. There is a need for information across all of the materials that go into building those facilities, as well as the raw materials that come in to make the product. There's a need for more data for us to be able to do anything but hand wave in trying to estimate the embedded carbon. And so on the solution providing side, we're working with companies like Johnson Controls, and I just cite that as one example, and there are many others, to provide sensor and silicon products and software that they can provide in their products to their customers, particularly in the industrial and commercial building space, to be able to reduce their footprint. And you have to have the data to be able to make a plausible case. And one of the things we've been looking at with the American Council on an Energy Efficient Economy is how do you turn from the kind of EM&V protocols that exist for many existing energy efficiency products, whether it's insulation or, windows, et cetera, where you've got fairly precise estimates. How do you do what I call good enough estimates for these IoT products in particular that will go in to make industrial operations more efficient, or go in to make a commercial building more energy efficient? We were starting to work with our customers to figure out ways to get approximate estimates of what we call the handprint. The handprint is how our technology can help other customers reduce their footprint. And it's a tough challenge right now, and it's going to require a lot of work. And a big part of it, I think DOE can help by encouraging the collection of more granular data on the carbon content of the grid at any given place at any given time. And in fact, in the infrastructure bill, our Digital Climate Alliance got inserted a provision that would have the Energy Information Agency work with industry to figure out ways to improve the granularity of data around, the grid carbon content at any given time, so that consumers can make choices about when they do their laundry, data center operations, where they're shifted, any load that can be time shifted can be informed, not just by the price of electricity, but by the carbon content. And then the final piece of it is there's increasing competition both within and between the concrete, steel, and wood products industries to try and prove which type of material is more climate friendly than the other. And then within each category, which company providing concrete or which company providing steel or wood products has the lower embedded carbon than their competitors. And what's needed there, as far as I can tell, is some development of standards, so that it's apples to apples comparisons when you look at the data. Right now, it isn't necessarily apples to apples, and the consumer in the building sector is left having to make judgments that would be better made if there was more information.
Yeah, those are great points, Steve. And I was thinking about quite a few of the things that we've been talking about internally in the Building Technologies Office at DOE recently, including development of some of the new tools coming out of the national labs, Cambium from the National Renewable Energy Lab, NREL, does what you said about accounting for how clean is the electricity in any one locality at any 1 hour of the day or whatever. So some great technologies coming out. Then it's a matter of, well, how do we implement those through real life supply chains? And that leads to the next question that I wanted to ask. And this is open to anyone who wants to take it. It seems like a lot of the issues we've heard in the news a lot lately about supply chain bottlenecks, and a lot of the issues you all are talking about in your comments have implications for the supply chain. So I'm wondering if any of you have any thoughts about how to streamline supply chain improvements in ways that will help us to get better products to market with fewer delays, because we all know that those affect how attractive any particular product or design decision is going to be, as can you actually get the better product. So any thoughts about supply chain that impacts these challenges in the built environment?
I mean, just a quick comment, Eric, would be that we're working more closely than ever with our strategic suppliers to ensure that backlog of orders that we're seeing for retrofitting buildings can continue at the pace they've been this year and even last year. And our backlog is very big, and we're working with those suppliers to make sure that we've secured the supplies to keep it all moving. We don't, although we're up against some of the nothing any more unique than any company right now, but for the most part, we have found a way to ensure that all those strategic parts and supplies that are needed will be available so we can continue doing what we're doing. Mm-hmm. I thought I would mention one thing. You mentioned building technologies, and I know that's your area. I mean, there's one technology I thought I would mention here. We didn't really get to it, but in terms of government partnerships and the government's role is one on something like electrification of heating, something that we believe is very much so needed as we try to take fossil fuel heating out of commercial buildings and homes. And I know that some of the other panelists have mentioned electrifying homes and commercial buildings, and there's a lot of myths that still exist across the marketplace around are things like existing heat pumps or the new heat pumps, are they applicable in all climates? And I know that DOE has announced just last week a new cold climate heat pump challenge. Mm-hmm. And I think this is a great role for government agencies like DOE to sort of take and demonstrate to the public that the technologies not only exist, but that they work. We know that they work, and we're placing them all over the world, but it's really great to see an agency take these challenges on to demonstrate and prove this out. There's a long list of things that we need to do that way, but I think electrification of heating is certainly something that we should explore.
Thanks for mentioning that, Scott. And I'll just add one little bit, which is that the Building Technologies Office at DOE announced in May, I believe it was, a new initiative. I'm not sure if it was May, but earlier this year, called E3. And if you just Google E3 and DOE or Building Technologies Office, you'll find the landing page for that program, which is specifically targeted at clean heating technologies, including heat pumps, but also heat pump water heaters and controls and all those technologies that are going to be needed to shift heating to cleaner approaches. So good news that we're both sort of thinking in the same exactly. way on that, and we expect to have more federal resources for that.
And here I would just, if I could toss in a here for that. We just completed our renewable heating and cooling plan in June, and found that all of Denver's buildings can be heated with heat pumps in the easier to electrify system types. It's often at cost parity with putting in a new gas system.
That's
today.
right.
So that's why we're moving forward with requirements to electrify existing buildings. And we did focus pretty heavily in Denver on partial electrification, because you can avoid panel upgrades if you keep gas backup. So heat pumps can handle our cold climate, but existing building electrical infrastructure can't always. But we can get 90% of the way there towards cutting heating emissions if we do partial electrification. So everything that Denver has is on our website, denvergov.org/energizedenver. So you can read all of our studies and reports there. And if I could do a small plug, we're hiring. So watch the website if you want to help us do all of this, because we need lots more people. We'll have 4 new people on my team in the next 3 months. So come help us decarbonize all the buildings in Denver.
Fantastic. So I wonder if we probably have time for one more question, and I'm wondering, Christie, if you had any comment on the supply chain issues related to, or anything else you might have in terms of how hard it's going to be to get new, cleaner, less embodied carbon emission products and materials into the marketplace. That seems to be one of the biggest barriers that we all have to face here, right?
Yeah, absolutely. Well, I'd love to address that question. And first of all, I'd also just like to emphasize and build off of what Stephen had mentioned earlier around measuring the carbon impact of building products, because you can't manage what you can't measure. Mm-hmm. And so it is really critical to get a baseline, to have an understanding of what is the carbon impact of one product over another. And it's really important to conduct proper analysis to compare those measurements appropriately. The best method that's available today is to request environmental product declarations, EPDs, which are kind of like nutrition labels for a building product, but it declares the amount of CO2 and other environmental impacts per unit of product. So that can provide a baseline, and with proper analysis, it could be used to compare the carbon impacts of different kinds of building materials. And it's really encouraging to see procurement policy and also private specification practices asking for EPDs. Even the new government infrastructure bill makes a mention to environmental product declarations. And so this is really encouraging to see. And that's another tool that can be used to measure. So I guess just to answer your final question of, what can be done, there are a couple of things. If you're in construction, I would first of all really encourage you to educate yourself further on Embodied Carbon, carbonleadershipforum.org, and understand what kinds of impacts come from embodied carbon, and take a look at the specification practices for all the different kinds of materials. Work with your engineers, work with the building product manufacturers to ask what kind of solutions are available and what kind of barriers do you see to introducing those solutions. Obviously, in procurement for public agencies, adopting policy and procurement practices like we're seeing at the City of Denver is another step in the right direction. And then if you're not, a procurer of concrete or part of the construction industry, but you're part of an organization that is on a mission to reduce your climate impact or become net zero, another option to consider is high quality carbon offset programs. So CarbonCure is really pleased to be part of the carbon dioxide removal industry and providing high quality carbon offset credits. And what this allows is it funds innovation that can make these kind of innovations more accessible to the industry to adopt and scale more quickly. And so it's a great way to support the decarbonization if you're not directly involved in construction yourself.
Well, thank you, Christie. I think that's a great way to sort of highlight and close out this panel discussion with sort of the sense that, wow, there's a lot going on. There's a lot of challenges, and there's a lot of people doing good work in the direction that we all recognize we need to go in order to decarbonize the built environment. I mean, we really just touched the tip of the iceberg today, and I wish this were a 3-hour. Part of me wishes it were a 3-hour time slot, because I'd love to dig deeper into some of these issues that each of you brought. But since we don't have 3 hours, I want to thank all the panelists, Katrina, for such a great example of what a local jurisdiction can do. Christie, for helping us have a little bit better understanding of what's going on the embodied carbon area and where we can go from there. Scott, for helping us to see what some of the corporate contributions can make to this big challenge, and Steve, enabling technologies like IT, how critical they're going to be to the solution. So this has just been fantastic, and I hope that everybody is encouraged by this panel discussion today, and that you'll keep looking into how all of these issues can affect your work going forward towards a cleaner environment and solving that climate crisis. So thanks for your attention today. I think it's time to hand over, because we've gotten to the end of our scheduled time, right?
Thank you, Eric. Thank you, Eric, Scott, Katrina, Stephen, and Christie for this great discussion. I learned a lot today, and I hope all of you did too. From how to reduce embodied carbon in buildings to innovative technologies that introduce recycled carbon dioxide into concrete to reduce its footprint, and also the role of digitalization to reach our climate targets using a more sustainable technological handprint. So thank you from our team here at the Climate Leadership Conference. We thank you for the discussion and also for your continuous work on climate action. As we wrap for the day, I would like to thank a few more sponsors for their support. Our silver sponsors, WSP, Edison International, Trane Technologies, the Nature Conservancy, TTE Group, Volvo Group, and PSG, and also our climate impact sponsor, Natural Capital Partners. To those in the audience, thank you for joining us today, and many of you yesterday as well who joined our workshop on climate risk, opportunity, and disclosure. We hope to see you back here in a few weeks as we host the final events of our 2021 Virtual Climate Leadership Series. Those sessions include our December 8th workshop on the fundamentals of getting to net zero, and December 9th, when we will host a conversation on investing in our cities through smart, resilient infrastructure. Be sure to register for those events on our website, climateleadershipconference.org. Have a good rest of your day, and we look forward to connecting with you all next month.